Right, hello, welcome back to another video. So in this one we're going to be having a look at the sine function. So this is using, this is one of the many trigonometry functions that are available. Note that some are also available as fast approximations. So some of these operations can be quite expensive, and so if you need the accuracy, then fair enough. If it's something you need an approximation or something you can get away with a quick approximation to, then there are some cheaper algorithms that calculate that. But the basic three trigonometry functions are sine, cosine, and tangent. And if we remember from doing sort of math at school, it is the angles in a triangle or in a circular motion. And so you have your sine wave that goes up and down, your cosine wave that does the same, but starts at a different point, either starts at the top or starts at the middle, and then your tangents, which is 1 divided by the other. If I do tan graph, and there we are, that's our tangent graph. So going up and then sort of jumping to the side, and you get a discontinuity in a tangent graph. But yeah, not going to go too much into trigonometry. Where a sine wave is useful is in animation, if we want to create any kind of repeating motion. So I have here another inbuilt function, plot function on graph. Really nice way to be able to sort of preview what's happening with our numbers here. And we're using some input data. It's hard to use sine waves without time, and we'll cover time more in the input lessons. But what do we have here? Well, we've got a representation at the top of the color. We are going into negative values, which Unreal can't render, so we just get black. But we can see this red line going up and down, and I might just slow it down with the speed parameter. So I'm just multiplying time by a value, effectively creating speed control, and then maybe that can see that a little bit better. So yeah, sine wave comes in. It has a input for the period. This is how long it takes for the sine wave to repeat. This is, I think, well, this is a black box. Turn the real time on. Real time. So another option here in live update is for real time nodes, so you can see that now matches what's happening here. These are disabled by default because they're using performance, basically. So if you've got the performance, then you can have them on, no problem. But if your material editor starts sort of slowing down, then maybe just turn these off. So yes, the period value in here. So this is giving us now a repeat of, well, in this case, because I've slowed it down, if I put my speed back to 1, it should be repeating every second, which I think it is. So every time it hits the top, we're getting a 1 second tap between that. This is a black box, so we can't edit this number sort of outside, but there's nothing stopping us doing this setup, multiplying by a speed. And we'll just slow that down again. So very useful for any kind of repeated motion, foliage movement, cloth simulation or cloth materials, that kind of stuff, all going to be done using sort of sine waves. In this case, we're just plugging in a single value, and so we're seeing that value going up and down. If we were to add a gradient beforehand, and we're using here the inbuilt function linear gradient, that just gives us a gradient from black to white across our plane. If we add that to time, so time multiplied by a speed, adding a gradient, and we get the ability to actually see the sine wave. So here, again, negative values not being rendered, so we get this white bump, and then there's actually a negative bump behind. And if we look at the function of that, we'll see we get our values going up and down. So very common, if you want something to move on its own, then that's going to give us sort of like a whole value everywhere. So a ball bobbing up and down, that kind of thing, you might just do with the sine wave. But if you're doing variation across an object, you might want to have some variation added before you then plug it into the sine wave, and that gives us this this waveform. Changing the gradient. So if I look at this next example, it's exactly the same. If I want to spread out those peaks and troughs by changing the gradient that I'm plugging in as the input, I'm going to get a change in wavelength. And so we have a speed control and a wavelength control. If I go very high or very low, we can see we get the different elements to that, and that's how we can control our animations. And so taking time, changing the multiplier of time to control the speed, and then we have our kind of variation creator, in this case just a linear gradient. This could be world coordinates, this could be a vertex painted mask, whatever it is we want to use, just to create variation about different parts of the mesh. And then by multiplying that by different values, we can control how fast, or the wavelength of our sine waves, how close together the peaks are, and vice versa. Next example, same thing. All I've done here is I've changed the period of these sine waves. So I've got 3 different sine waves happening all with the same speed and all with the same wavelength, but with slightly different periods, so they're repeating at slightly different times. And if I look at the function of that and make my wavelength slightly higher, there we are, we can see we get quite a lot of variation. It's still a repeating wave, it will just repeat over quite a big period now, but by combining the 3 things together with slightly different values, where the peaks combine and sort of align with each other, and let's just do this. So here we are. So this is the first sine wave. This one is at a slightly different values, and then the third one is obviously slightly different values again. So where all the peaks combine, we get a peak, and where the peaks cancel each other out, we get a flat area, and we can get quite a lot of variation. So I'm just adding them together, dividing by 3 or multiplying by 0.3 in order to get them back to 0 to 1, and we can see we get this kind of shape here. And changing the periods of these is going to give us different waveforms with different variation. So a really nice way to create random motion. So things like foliage or cloth, where you want it to move randomly but not to be too repetitive, you might want to combine different sine waves. Worth noting, you probably don't want to use something like 1.5 and 2, because the sine wave of 2 is twice the sine wave of 1, and so they're no longer giving us that sort of interference pattern. We're just going to get the peak here cancelling out with the peak in this one. So just be careful about what numbers you're using. Try and make sure that the numbers don't automatically coincide with each other. So what I've labelled here, 1.25, 1.33, works quite nicely as a sort of baseline setup. They are similar but different, and they are different in a way that they don't combine with each other. So yeah, it's very, just be careful not to use 1, 2, 3, because that won't give us the interference pattern that we're after. Okay, a couple more examples. Linear sine. So this is a again inbuilt function, just giving us a straight line direction between 2 things, and you can use a rounded linear sine as well. So straight lines with a little bit of curvature. Same kind of setup. Again, if you want to go into the math of what's happening in here, so they're doing it that way. And where's the linear rounded there? Okay, yeah. So just blending between values. They're not using sine waves in here, but they're giving us a kind of straight line version of that, which works quite nicely if you just want something that's a bit more mechanical. And then lastly, there is another inbuilt node, debug time sine. This is a simple sine wave, just remapped between 0 and 1. So if you want to drop in a quick test node that just gives us values that vary between 0 and 1, debug time sine does that quite nicely. And what that's using, if we open this up, is this node here, constant bias scale, which is actually our future example, our next one here, constant bias scale. So we'll just cover that now as well. What this does is it takes an input and it just doesn't add and multiply at the same time. So for example here, if I look at the values, we have time going into a sine wave. Well, the default of time into a sine wave is +1 to -1, and you can see those values going up and down a little bit fast. Maybe I'll multiply by a speed, just multiply by 0.1. There we go. So we go up to 9999 and down to -999. Well, that's fine. If we want to adjust those ranges, well, if I add 1, our top range becomes 2 and our bottom range becomes 0. Let's try and do this. So we're starting at between 0 and 1. If we add 1, the whole thing moves up, but now our highest value is 2. To get that back to 1, we multiply by 1/2, and that will now give us 0 to 1. So the constant bias scale node just gives us a way of doing a multiply and an add at the same time. Up to you if you want to use it versus just using 2 nodes, exactly the same under the hood. But the default settings for constant bias scale, if we create one, are designed to go from -1 to 1 to 0 to 1. So now we're going to 0 and we're going to go up to 999 effectively. There we are. If we look at that as a function, going from 0 up to 1. The invert, if you're in 0 to 1 and you want to go back to -1 to 1, if I do this, it will be a bias of -1 and a scale of 2. And I need to plug that into my function. Oh, no it won't, that's a lie, -1/2. There we go. So we start at 0 to 1, we -1/2, so we're at positive -0.5, and sort of equally scaled around the 0, and we multiply by 2, and we stretch up to -1 and 1. Yeah, but actually exactly the same as just using an add and a multiply at the same time. There's also another input or inbuilt function, remap value range. This works in the same way, but for any general case. And so you have an input value, in this case our sine wave, and let's just have a look at this as a function on a graph. And we have told it what our input high and low are, in this case 1 and -1, and we've told it what our output high and low are, in this case 1 and 0, and so it's remapped those values. If we wanted to remap to say 0.5 and 0.75, we could do that. So we're plugging in what the input is, and then we're plugging in what our output are, and we'll get a small sine wave between those two. So a bit of an ease of use thing if you're dealing with sine waves and you want the final output to be not just 0 to 1, you can use this remap value range and it'll change those values accordingly. Okay, as I say, we'll cover sine waves and things more in future lessons, but they are very useful for doing any kind of animation in materials.